Oh, God.
Just hop on the train. Yep. All right, so let's go ahead and get started. So last time we started to talk about structures already, and today we'll kind of continue with the discussion of structures. In terms of time allocation, it's only like 1.5 hours, okay, 1.5, which is 1 hour and a half, which is about one class. That's the allocation of time. But structures are actually far more important and far more, it needs more time than 1.5 hours to talk about what structures are and what they're useful for. Okay, so what we'll do is we are going to continue with the discussion of using date as a structure. And then what we'll do today is to actually implement a small program so that an end user can input 2 dates and they can tell you whether the first date is after the second date, because that's what we were talking about as a quote-unquote application. So we'll go ahead and start with that. Okay, let's see here. All right, so what we'll do is I'm going to rewrite the entire program from scratch. But you know what I'll do? And I'm going to do it the right way. So I'm going to separate this one program into several files. There'll be at least the main file. Okay, the main file is the entry point of everything, so that's kind of important. I will have one file to deal with the input of a date. I'll have one file to do the actual comparison. And I'll have one extra file, which is my own header file, for the definition of the structure itself, which has to be shared with all the CPP or all the source files. Okay, so I'm going to end up with like 4 different files for this particular program, and to get it to compile and link is going to be quite a chore, because I have to compile 3 different source files into object files, and then link the 3 object files into the executable. So I'm going to do it at least for now without using an automated tool. Yep, go ahead.
I was just going to ask, are you separating the subroutines into their own files?
For the most part, yeah.
Could you not just run it from subroutines instead of their own separate file?
You can combine everything into one single source file, but that makes the organization of the program a little bit chaotic. When you're writing programs for homework submission, it's not an issue, okay? Because most homework assignments are quote-unquote self-contained, which means there's no component in one particular homework assignment that you have to reuse in another homework assignment or reuse by somebody else. But when you're working in a work environment, a lot of times you work on a utility subroutine to do something. But that subroutine is also going to be useful in other projects, other programs than the one that you're actually developing. So if you put everything into main.cpp, then you're dealing with copy and pasting from your source code into the next project. And remember what we talked about last time? Copy and pasting is not a good thing. So if you can avoid copy, paste, and modify, you should do it. And this is one way to avoid that, is to separate or extract all the components that you think might be reused into separate files. So this way, you only have to share files between projects. And that can be done easily using a revision control or using the file system of any operating system. Yep, go ahead.
Are you recording?
I am recording, yes.
Perfect.
And
Okay,
double check on the channel. Okay, yep, it is recording.
And one more question.
Yep.
So when we separate subroutines like that, it's as long as it's above main, it's gonna work the way it's intended. When it's called within the main to the subroutine?
Well, that's a good question. We'll explain all of that stuff today. So today's class is not just about structures, but it's also about how to reuse code in C and C++ using different files, using the header file, and also using what we call prototypes of functions. So there are several aspects of today's class that are, I think, would be very important in C and C++ programming. Not only for your homework assignment, this is the kind of stuff that you need to know when you're working as a developer or as a software engineer. Okay, so let's go ahead and get started with this particular program. So I'm going to start with main.cpp. This is also called top-down design. which is also something that we need to understand is how do you design a program in a top-down fashion. Okay, now what exactly is top-down? Top-down design.
It's the hierarchy. So
Is a hierarchy.
So you do 1 before you do 2,
Right.
before you do 3, before you do 4.
Kind of like that. It's also how you organize or how you plan for the writing of an English paper. How many people are now taking is it English 300, the one that you have to get through with GE? Okay, is that a writing class?
Yeah.
So what is the typical length of a particular essay that you have to turn in?
1,200 words.
Sorry?
1,200 words.
1,200 words. Okay. So with 1,200 words, of an essay, how do you write something like that? How many people can start from the very beginning and just keep typing without ever having to change anything, and you're done in an hour? No way. So how do you write an English paper that has the complexity of at least 1,200 words? Is it 1,200? Yeah. So 1,200 words is not really a lot, but it still requires a lot of planning, right? So how do you plan the writing for something like that? Yep.
Well, there should be a thesis, body paragraphs, an introduction, and a conclusion.
Exactly. So you identify all the major components of an essay first, right? That is top-down design already. Okay. So you have just described the top-down design approach. You guys okay?
Yeah.
Okay. So you have just described the top-down approach, but applied to writing an English essay. Okay. So why do you think writing a program is not that much different from writing an English essay from the organization perspective? Who's the audience when you write an English paper?
Your employee, your employer.
Yeah. No. Just here when you write your professor, right? Okay. But your professor is actually reading it from the perspective of somebody else, right? Somebody who needs to be convinced of something. So you have to write an argumentative essay, or you have to write a descriptive essay. If you want to describe something to the audience, or whoever is going to read it. But when you're writing a program, you have an audience too. You have a readership. Who's going to read it?
Other programmers.
Very good. You are both right. Okay, and that's both important. Okay. When you're writing code, you're writing the code so that the compiler can read it, eventually compile, and be able to run your program. That is important. But at the same time, you're also writing it so that other people can read your code. Okay? So from that perspective, writing a program is about the same as writing an English essay. Okay? Because the complexity of one program is too much to write it from the start to finish in one single shot. So you have to organize your program. And that's exactly what I'm going to do here. Is I will go to main, and I'm going to say, let's assume, okay, so I'll just be lazy here, and I'll say, assume date is defined as a type, okay, as a structure. So the way I write this program is going to be like this, and what I'll do is I will say, okay, I have date1 as D1, I have date as D2, so now I have two variables. Remember, date starting with the uppercase D is the name of a cookie cutter. Okay, that is the template. That's how we create variables. It is the type. D1 and D2 are the names of the variables. They are the cookies cut out using the cookie cutter called date with the uppercase D. Are we doing okay so far with those concepts? We kind of briefly talked about cookies, and someone actually brought me a piece of cookie after class. Okay, so now we have two variables, D1 and D2. I don't know exactly what date is, how I'm going to represent a particular date. I'm just going to say that there is going to be a date type, okay? And I don't really care, how it's done at this point. And then the next thing I'm going to do is to say, oh, you know what? I need to read a date from standard in. So I'm going to say read date, and I will read it into D1. Now here I have a choice. I have a choice of either using pass by reference or passing by value, but using the address of passing by value. Okay. Since I'm teaching C++, we'll go ahead and use the C++ only feature, which is passing by reference. Passing by reference is actually an easier way to do it because you don't have to use the ampersand operator to extract the address of something. And then the other nice thing about doing this is you won't run into problems like dangling pointers and stuff like that. So this is really the kind of the recommended way to do it. I'll have the same procedure to read into D2. Okay, so we have D1 as a variable. After line 8, it will have an actual date that I read from standard input. D2 is the same way. I'm going to read it from standard input. And then I will say, is date greater than, so that means if the first date is greater than the second one. And guess what? I'm going to pass D1 and D2 as my parameters. In other words, what do I need to compare two dates? The two dates, right? So I have D1 and D2 here as the two dates to compare. I'm just asking, is the first one greater than the second one? Is the first one after the second one? So you have a choice, if you want to. If you don't like the word, greater than, you can always say later than, or after. Okay, they mean exactly the same thing since we're dealing with time here. Okay. And from here, I can now just say, C out, std standard out, C out, and just make a conclusion, okay, and say the first date is after the second date. Okay, so this part is nothing more than just a feedback so that we can see the actual outcome of the program. Okay, else. Yep, go ahead.
Is it simpler to just declare the namespace std on top?
I have a
The
problem.
library?
I have a problem with using namespace because it defeats the whole purpose of having namespaces to begin with. Because when you say using namespace std, it's bringing in all of the names included in the namespace std into the quote-unquote default namespace.
Mm-hmm.
But if you do it several times, then you end up with the same problem as what C++ programming had to deal with before they had namespaces. So from that perspective, yeah, you're saving a few, strokes of a keyboard typing std : but in a certain way, you're kind of defeating the whole purpose of having namespaces as a feature of the programming language to begin with. Yep.
What was the command you did to yank the line?
To what?
To yank the
To end a line?
No, to copy.
Oh, to yank. YY, lowercase y, and then lowercase y again to yank, which is to copy into the clipboard, and then to paste is lowercase p. So that will paste after the current cursor.
This is after you exit the insert mode, right?
You do this in the actual editing mode. So you say YY here, and then you just go to wherever you want to paste and say P. All right, so that's my entire program. All right, now we have some serious issues with this program here, okay? But you can see that when I write this code, I'm not really too concerned about the details, okay? What is the type date? Somebody's going to do it. What about the subroutine read date? Somebody's going to do it. What about the function is date greater than? Somebody's going to do it, okay? So I'm deferring a lot of stuff to quote-unquote somebody else, okay? The only thing that I also need here, at this point I know for sure I need, is to pound include IOStream because this is the only way I can use cout and cin, okay? All right. So as it stands right now, this program is not going to compile, right? Why would this program compile? It cannot, right? Why do you think it's not going to compile? We're missing something here. The definition of date, as well as the subroutines, okay, to deal with the date type. Sorry, go ahead.
Oh, no, sorry.
That's okay. As long as it relates to the class, you can just kind of speak it out. Speak it up. So we need the subroutine read date. We need the subroutine is date greater than in order to make this program compile. Okay. So what I'll do next is I'm going to write a new file. Okay. This new file is I'll just call this date.h. Okay. It's a header file. Okay. And in this header file, I'll do one kind of funky stuff here. This is, some people consider this kind of more advanced programming topic, but I think you need to know it from the get-go. So I'll do it first, and I'll explain what it is. All right, so let me just kind of explain what line 1, 2, and 6 are doing. Line 1 and line 6 is basically marking the beginning and the end of a conditional, quote-unquote, conditional statement. But in this case, it's not exactly a statement. It is a pre-processor feature. Every time you see something that begins with a pound sign all the way to the left-hand side in C and C++, it is intended to a component that we call the C preprocessor. Okay? The C preprocessor is basically just a text processor. In this case, it is testing whether a particular macro is defined. So N stands for not, def is defined. So this is basically saying if not defined, and what are we checking, whether it's defined or not? It's just this macro name. It's called a macro. It's basically just a symbol, but to the macro processor or to the C preprocessor, it is a name that you can check. So it's basically saying if date underscore date underscore h is not defined, then we'll do the following. What if it is defined? If it is already defined, it skips all the way to end if. So nothing in between is going to be a part of the program at all. Okay. So on line 2, if we get to line 2, it means underscore date underscore h is not defined. So what we do is we immediately define it. Well, that seems to kind of defeat the whole purpose, right? But what this is really doing is to say, if I define this several times, it will skip the second and all the subsequent occurrences, will not recompile what is going to be on line 3, 4, and 5, and so on. Okay. Let me show you what exactly this is for. So I'll go ahead and define the structure for date. And you know what? At this point, I don't really know what it's supposed to be. That's okay. I'm just giving it a stub to basically say, yeah, I'll fill this in later. Is that okay so far? But nonetheless, from line 4 to line 6 at this point, it is a structure definition. Okay, it is telling the compiler we are defining a particular structure. It is called date, and currently it has no memory. There's nothing inside. Okay, we'll fill it in later. So what I'll also do is I'm going to comment out the pound lines here. Okay, so we'll go ahead and see what happens if those are all taken out. And we'll go back to main.cpp, and now I can include my own file, which is date.h. Now, when you include your own header file, one thing you have to change is instead of using the angle brackets, you have to use double quotes. The angle brackets are only useful when you're dealing with files that are supplied by the system. But when you're referring to your own header files, you have to use double quotes. Are there any questions about the convention? So what this is, what line 1 is now doing is to say, okay, let's bring in everything that is in date.h as if it is a part of this program. And what did we put into date.h? The definition of the date structure, right? Okay, it's empty right now, but it is there. Okay. All right. So let's go ahead and let's compile this program the way it is right now and see what kind of complaints we're getting. It's going to complain big time, but we'll try to check how much it's going to compile. So we'll write a file, we exit from the editor, and then we say g++ -1 all -pedantic -c. Now we don't want a -o because I know for sure we're not ready to get an executable. I just want to compile at this point. Okay, I don't want to create an executable just yet because I know for sure that's not going to work. Okay, so -c is just compiling main.cpp into an object file, and right away we're getting some complaints here, which is probably what you expected, right? It's complaining read date as a function was not declared. It's complaining is greater than is also not declared. Now, when it uses the word declared, it is simply saying that nobody told me how to use read date. Nobody told me how to use is date greater than. Okay, a declaration is just that. Okay, how do we use it, as opposed to the definition, which is how is it implemented. Okay, Okay, so let's go ahead and fix this program. The one place that I need to fix is not in main.cpp. I'm going to fix this in date.h. Okay, so date.h is the header file that includes just about everything that I want to do with the type date. Okay, so now I have to include the definition of the two subroutines that was complained about earlier. The first one was what? Read date, right? So we'll say that read date as a subroutine is not going to return any value. Okay, it's not going to return anything. Yep, go ahead. Okay, and it has one parameter. The one single parameter that it has is of the type struct date, and it is passed by reference. When you pass a parameter by reference, you use the ampersand symbol to mean that it is now passed by reference. Passing by reference means the subroutine has the ability to find the original thing, so it will change the original thing. If you specify the parameter without the ampersand, it's going to be passed by value, which means the subroutine only has access to a copy of the original item, and it doesn't work with reading, because when you're reading something into date or D in this case, you want to change the original item. You don't want to change just the clone, only to throw it away. Okay, and I put a semicolon here. Now this semicolon is significant because what this means is line 8 is a prototype. Okay, a prototype of a function is a declaration. It simply tells the compiler, you know what? When you see read date as a subroutine, expect a single parameter of the type struct date. That's all it's telling the compiler. It's not telling the compiler how it is done. Oh, you have to use cin or da 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 da. It's not saying how it is done. It's simply saying how to use the function itself. Okay. In a way, it's kind of like, if you want to think about it, a prototype is more like the front part or the top of a remote control. Okay. You press the power button, it turns on something. You press it again, it turns off that something. Okay. You press, assuming this is a TV remote control, it has a volume up and volume down. So when you press volume up, it increases the volume. When you press volume down, it decreases the volume. That is the prototype. But how is it actually done? What about the circuitry inside the TV that actually controls the volume of the speakers? That's the definition, which is currently missing. So this is really just describing what buttons are on the remote control, but not the electronic circuitry inside the TV to implement what a button really is meant to do. Are we doing okay so far, separating, how to use something as opposed to how it is actually implemented? Is that okay? Because that's going to be a very important topic. Go ahead.
So we made a prototype date age. Does this source file need to be in the same folder with the other program?
It doesn't have to be. If it's not in the same folder, then when you specify the double quotes, you have to specify the relative path or the complete path to the
That's
input
what I was
file.
trying to ask about.
Yep.
So how do you specify the path?
You can use all the files as path specification. A slash at the very beginning means the root folder, or you can use the dot to mean the parent folder, or if it is in the subfolder, you can say subfolder 1 slash and then the name of the file.
Okay. But it starts with a slash most of the time?
If you start with a single slash, it means you're using the absolute file path, which is kind of cumbersome to use for the most part. So usually you use what we call a relative path, which is saying, okay, from the current folder, how do I get to the header file? By traversing to the parent of the folder or a subfolder of the current folder.
But it's the most convenient to have it in the same folder?
Yes. Now, if you have the same header file but it's being shared by multiple projects, there are several ways to synchronize that. One thing you can do is to create a symlink so that it appears to be the same file, but take it back. Appears to be different files in different folders, but because they are symlinks or symbolic links to each other, they all link back to the original file. So you can use several ways to do it. At least in Linux you can. In Windows, they have a concept of a symbolic link too, but it's usually not used. It's not the same thing as a shortcut.
But in this case, we have this source, this prototype in the same folder.
Yes.
Okay.
And that's why we can just say the file name itself, because by default we are looking for the file in the current folder.
Okay. Thank you.
Yep.
So how would this file be shared in an environment like this? How would that guy be able to get to it, or how would you be able to get to it?
That's a good question. I'll answer that question after I get the second subroutine done, then we can answer that question. Okay. So the second one is, to return an integer, which is actually being used as a Boolean, is date greater than, and it has two parameters. So in this case, the two parameters, I'm going to use the right one, and I'll explain what it is. Okay. Now this is not the only way to do it, but this is the right way to do it. Okay. So let me explain what these two parameters are. This one is easy. This is not a parameter. That's the return type of the subroutine. It returns an integer. Remember, an integer of 0 means it's false, and integer of non-zero means it's true. That's basically being interpreted as a Boolean. So what is kind of mysterious is this thing here. Okay, it's really kind of long as a parameter, but each component serves a particular purpose. Let's take a look at the first one here, const. So when you use a const keyword, it means this particular parameter is not supposed to change. It is not supposed to be changed by the subroutine is date greater than, which is basically saying when you compare two dates, you only need to read or know what the dates are, but you don't need to change it because you're not reading into the parameter, as opposed to read date, which has to change the parameter itself. Is that part okay? So a const is really important because without const as a keyword here, and if you accidentally use a equal symbol instead of equal in the definition of the subroutine, the compiler won't be able to catch it. And then you end up changing one of the dates or one of the components of a date when you're accidentally just trying to compare. Okay? When you say const and you make the same error, the compiler will come back and complain and say you're not supposed to change these two dates that you're comparing. So it gives you one additional layer of protection because now the compiler understands that this subroutine is not supposed to change the parameters. Okay? The second component is it's basically the type of the parameter itself. It's just kind of like on line 8, D is of the type struct date. In this case, D1 and D2 are also of the type struct date. The ampersand means it is also passed by reference. So in this case, passing by reference is really not necessary, okay? Because we are not changing it, right? If you're not changing it, why is it passed by reference? In fact, if you think about it, const and pass by reference, they seem to be contradicting. Because on one hand, const means what? You're not supposed to change it, right? And passing by reference seems to imply that you have the ability to change whatever the parameter is trying to pass. But they're not really contradicting in this case, because when you have a structure or when you have a type that is really kind of big, takes up a lot of memory storage. So instead of making a copy of that whole thing, which takes up time and also memory space, if you just tell the subroutine how to find the original item, it is much more efficient. Okay? Is that making any sense? Sort of? Okay. It's kind of like, okay, let's say I make a subroutine to count the number of a particular word in a book. Okay, word count, just search for occurrences of a particular word. So let's just say that we are dealing with a really thick book, in this case a 300-page book. Is it more efficient to tell the subroutine, hey, this is the call number of the 300-page book, go find it yourself and count the occurrences, the number of occurrences of this particular word? Or the second way, which is make a photocopy of the 300-page book, give the subroutine the 300-page book, the copy of, and then have the subroutine to, okay, now count the number of occurrences of this word. Either one will work correctly because the original item is not getting modified. But the first way is more efficient because you're not spending your time and paper to make a photocopy of something that you did not have to make a photocopy of. So that's why it is being passed by reference here is for efficiency. And that's why passing by reference in this case, for efficiency purposes, does not contradict the first keyword here, which is const, which means, oh, you know what? This is a book of the library. Don't mark it up. Okay, so those two things are not contradicting. You have a call number, and you have a little note saying, do not mess around with this book. Do not destroy this book. Do not write over this book. All right. So with just two prototypes, let's go ahead and compile the program again and see whether this is okay. Oh, it is okay. Okay. So wow, hold on a second here. Let's think back to what we just did. We have a type definition that is empty, nothing, absolutely nothing in date. We have a prototype of read date, and we have a prototype of is date greater than, which only tells the compiler how to make use of the subroutines, but not exactly how it's done. But yet the compiler is completely happy about this and say, yeah, it's okay, not a problem. Well, that's because the compiler is only there to compile the code. It is not the linker. Okay? Because right now, okay, let's go back and look at what kind of files we have at this point. We have the two files that we created. We have date.h, which is the header file. We have main.cpp, which is the source file. And this is the result of compiling a source code. It creates an object file. The object file at this point has two unresolved references. One to the function called readDate, and the second one to the function called isDate greater than. And they're unresolved because nobody is supplying the definitions of those two particular functions. But the compiler is not, to the compiler, it is not a problem. It is just because a compiler is nothing more than a translator. It is translating a book from one language to another language. If one particular book has a reference to a particular name, and it doesn't explain what that name really is, it's not a problem. The translator just says, okay, this is referring to a particular name. In the translated version, I'll also refer to that name. That's all I need to do. It's the linker that has to do with, oh, okay, I need to make sure that all the unresolved references are done when the entire book is done. This is one chapter of a book. It can have unresolved references. But when you combine all the chapters, then you better make sure that all the terms are explained somewhere in the book in some chapter. Is that okay? Is that analogy working? Each object file is basically just one chapter. Oh, okay. All right. So let's go back to the original thing that I wanted to demonstrate, which is this thing here. Okay. So what we'll do is we'll go back to main.cpp and say, what if I do this? Oops. What if I do something like this? What if I pound include date.h several times? And the most immediate response is, what kind of a dumb programmer would do something like that? Right? Well, it is not intentional. It's not going to be intentional because you can use a pound include inside a header file. Okay, let me say that again. Inside one include file, you can make it include another include file. So header files can stack, basically. They can be hierarchical. And that's only because you don't want to repeat the definitions over and over and over again. If one particular header file has the definition of something that you need, you just say, oh, pound include that header file over there. But how can you be sure that another header file in the source code itself has not already pound included that particular header file? You have absolutely no control, right? So eventually, you still end up with this kind of situation, okay? It's just that it's not direct, it is indirectly pound including the same header file multiple times. So we want to know, how is the compiler dealing with, multiple occurrences of the same thing. So let's go ahead and, ask the compiler, okay, tell me, is there a problem? And it says there's a problem here. The problem is on the same line. If you kind of scroll back, it is always complaining about line 4 of date.h. It's complaining that struct date is being redefined in all the other extra pound includes. But that makes sense, right? Because you can only have one cookie cutter called date. And by pound include date.h several times, I'm now redefining the same cookie cutter. I'm trying to reuse the name date on several cookie cutters, and that's not allowed. So how do we deal with this? How do we deal with this problem? We go back here and we uncomment this stuff here. So now we start to understand why it is here. Because the first time we do the pound include, the underscore date.h would not have been defined because nobody defined it, right? The first time. So it will go on to move on to line 2. Line 2 is actually going to define the macro underscore date underscore h to nothing. Okay? The actual definition is not important. You can define the macro to something, but in this case I just need to say now this macro exists. That's all it's saying. Yep, go ahead.
The date underscore age, do we exactly need to have all those underscores there?
No, it's just because it's not a normal macro definition. I just use 2 underscores preceding it to basically say this is not a quote unquote usual macro. Yep.
But you can call a macro any way you want.
As long as it is consistent, as long as this macro, the checking of the macro is consistent with the definition of the macro, you'll still be okay.
Okay.
Yes.
Okay, so is it case sensitive?
Yes, it is. This is a macro definition, and by convention, macros always use all uppercase. But that's just a convention. You could have used the lowercase, and the macro, the preprocessor would not have cared. But by convention, you use all uppercase when we are dealing with macros.
So for other programmer readability, it's better to have that.
Correct, because they can tell that this is a macro definition just by looking at how we use uppercase and lowercase, or the lack of lowercase in this case. Okay, so this is really useful because the second time we include this header file, it will encounter line 1 again, but the second time when you're asking is underscore date underscore h not defined, the answer is false, right? And if the answer is false, it will skip everything. The compiler will not see any of this text here, and it will resume, at else if there's an else, or it will resume after line 11 if there's anything after line 11. So that's why this is important, because it makes sure that the content from line 3 all the way up to line 10 is actually only going to be included exactly once, even though the header file itself is pound included multiple times. Okay. Well, but we can check it, right? Compiler is happy now. All right, cool. But if I try to link this program, it's not going to work. Okay, G++ -O, with a -O, it means we are linking the object file into executable. So now we want to link to the executable called main from the object file from the previous step. And the compiler complains, and we know exactly why it is complaining, because we already knew about it, I talked about it, but the error message from the linker is saying the same thing too. Undefined reference to read date, undefined reference to read date, because there were 2 occurrences in main.cpp, and then 1 undefined reference to is date greater than in the body in the conditional statement. So are we doing okay so far understanding why we are seeing these error messages at this point? Is that okay? All right. So now it's time to define the other 2 files. So I'm going to use 1 file per function. So the first one, I'm just going to use readdate.cpp, of the same name as the subroutine itself. Okay, now we have a question here. Should I kind of redefine structure, date here, blah, blah, blah? Why not?
We've already done it once.
Remember that one thing that I talked about last time? If you are copying and pasting, that's usually not a good sign. What did I just do? Copying, right? Not a good idea. Okay, if I'm not going to copy it, what can I do?
Modify.
Sorry?
Modify.
Modify? From where?
From the original.
But anything that has to do with copy, paste, and modify is not good. Okay, so give it a try.
You can refer to
Very good. Refer to what?
the subroutine to define.
Not the subroutine. I can have to refer to the header file,
Yeah.
right? So I have to refer to header file date.h, which also means that I have to pound include it. Okay, this is why we have header files. Okay, if you have any type of declaration or definition that you want to share across all of the source files of a project, put it into a header file. Then you can pound include the header file from all of the source files. Are we doing okay so far? Why the header file is important? Yep, go ahead.
I'm sorry, you're probably going to get to the question.
No, go ahead.
Okay, so you stated at least twice already in the last 2 minutes that you can include this header file in the directory. But how does someone else get to it?
How does another project refer to it?
Yes.
Okay, let me handle that one next. Okay, so we'll deal with this one first, and then we'll deal with the other one. Okay. All right. So yeah, I'll deal with that next.
So this is all with the assumption that it's all within the same root directory.
Within the same project directory, yes. Okay, so now we want to define read date because that's the name of the file itself. So read date has one parameter, which is a struct date. It is passed by reference, but I'm not copying and pasting in this case because in the header file we have the prototype. This is not a prototype. This is the actual definition of the subroutine, and this is the way I want it at this point. I'm not doing a single thing. Okay, this is what we call a stub. Okay, a stub is basically just the body or the definition of a subroutine that really doesn't do anything. Okay, but it does make the compiler happy and it makes the linker happy because now we do have a subroutine called readDate, except it doesn't do a single thing. Okay, well, that's fine. So we'll just leave it the way it is, and we're going to create the third file, the third source file, which is date greater than. Should have picked a shorter name, but that's okay. Okay, we'll do the same thing. Pound include date.h, which is the header file that includes the definition of struct date itself, as well as the prototypes of the functions related to date. So now we can say int is date greater than, and this time we want to use const struct date ampersand d1 as the first parameter, construct date ampersand d2 as the second parameter. And I'm just going to return 1 here. It's not doing any computation. It's not actually checking anything. It's just going to return the 1 regardless of what d1 and d2 are. All right. So once again, we have a stub. Okay, this is a stub function. It doesn't actually do anything useful, but it makes the compiler happy. It makes the linker happy too. Okay. So now we have the third step. Okay, when we have both of these, quote unquote stub subroutines done, we'll go ahead and compile these two source files. So once again, we use G++ and change main.cpp to readDate.cpp, and also to isDate greater than .cpp, and all of those compile without any problems. Okay, so when we look at the folder, we have 3 object files at this point. We have isDate greater than .o, we have readDate.o, and then we have the original main.o. Okay, we can link these files now. So we can say G++-o, which means we want the actual executable file this time called main, and then give it all the object files as the input to the linker. So we got main.o is date greater than .o, and also readDate.o. And the linker is perfectly happy about this, right? Because everything, all the unresolved name in main are now resolved. Remember, each object file is like a chapter of a book. by the chapter itself, it can have undefined names. Okay, it can have what we call unresolved references. But when you compile the book itself, when you put all the chapters together, you better make sure that if chapter 1 refers to chapter 2 and chapter 1 also refers to chapter 3, that chapter 2 and chapter 3 are a part of the entire book itself. Is that making any sense? And that's what the linker is doing. It's actually putting all the chapters together and make sure that all the references from one chapter to the next, all of those references are resolved at this point.
Is it matter where you put the file name at? Let's just say that you have the main.o at the end. Does it matter?
.o is the default extension of an object file. If you do it in Windows, it is obj.
No. I mean, if you leave it at the end, like, let's say that you have the each day greater than, and then days, and then end, is that okay? Or does it have to be main first and then?
Yes, it is important because .o, this file, main.o is date greater than .o and readDate.o. Those were created by default by the previous process. The compile process automatically creates these names or these files with these names with a .o extension.
He's asking if, does it matter if you change the place where you're putting the name?
Oh, the ordering.
Yeah.
The ordering is not important.
Okay.
Okay, sorry, I misunderstood.
No.
No,
Yep.
but main.o is the top down that you want to work with.
No, by the time you get to the linker, it really does not matter. In other words, you can put main.o as the last one. It will still link just fine. Yeah. So now we can actually run it. So when I run this program, what do you think it's going to do? It will just say the first date is greater than the second one, right? Without asking me to enter either one.
Right, because you had no standard
Because you had one.
.cn.
Because everyone is a stub,
Right,
and is date greater than returns 1 all the time.
right.
Which means it's always true that the first date is greater than the second date. So when we run the program, yeah, sure enough, it's a completely useless program.
But functional.
Well, it compiles, so it gives you a starting point, okay? And 2, we have all the actual stub definitions. Now this part is also important. When you define your own types like this in main.cpp, is there anywhere in main.cpp that I need to look into what is inside a date? Like a date is represented as the number of seconds since 1970, or is a date represented by day, month, day of month, year, month, day, and day of month? It doesn't say anything, right? It just says, oh, there's a type, magical type called date with an uppercase D, and it is capable of representing a date. But you know what? From main's perspective, that's all it needs to know. There's nothing else it needs to know. It doesn't need to know what is inside a date. It just needs to know a date object or a date variable can represent a date. That's all it needs to know. For all we know, it can be star date representation, right? Is that okay so far? So if I make changes to the definition of date, do you think I need to touch main at this point, hereafter? None whatsoever. Okay. Now this concept is called encapsulation, but not encapsulation. This is called abstract data type. It basically means you have to cleanly separate the program into 2 parts. Whenever you deal with a type definition, like in this case, a struct date, you separate the program into 2 main parts. One part has to know or deal with the inside of a date. So that would be readDate.cpp and is date greater than .cpp. Because those 2 need to understand, okay, how is a date represented so that I can either read from the standard input file or I can compare using the comparison, right? But you also have another part of the program called the consumer, quote-unquote consumer of the type, which is our main.cpp. That part does not need to know what is inside a date representation. Okay. It is also similar to a remote control. Okay. To the rest of the program. Okay, let me just kind of flip the question. Do you ever need to know how a LCD TV is done, or what is HD TV, as a reception, as a radio signal, how it is implemented? When you switch over from the early, fish tank TV using the traditional broadcast, signal to your brand spanking new HD TV that has an LCD screen, do you need to understand? Oh, you know what? I can see that HD TV uses this type of carrier frequency, this kind of encoding, as opposed to traditional broadcast signal, which is analog, uses all this kind of standard to do the broadcast. Did you have to know that? No. What about changing the brightness of your TV? Did you have to open up the case of your TV, your fish tank, and wear really thick gloves, just so they don't get zapped by the high voltage, and tweak something inside the TV? It's like, okay, I think I need it to be a little bit brighter. Turn this knob a little bit here, put the cover back on, and sit back and relax. And as opposed to an LCD TV, where you change the bias voltage to the liquid crystal to change the brightness. Did you have to understand all of this stuff? No. So how do you change the brightness or the contrast of your TV?
You don't.
Huh?
You don't.
You don't. But if you do need, what do? Well, change channel. Okay, change channel. I mean, I'm pretty sure you change channel once in a while. Right? So how do you change channel? The remote control. But the remote control looks the same, right? From the old TV using the traditional broadcast signal to the HD TV, the remote control looks almost the same. Okay, there might be a few buttons that are new, but for the most part, they're the same. That is what we are talking about here. Okay, I should be able to change the representation of a date and not impact the majority of the program itself. And someone would argue and disagree. This is actually not a whole lot of code, so if I need to refer to D1 dot something, it should be fine. But in a real program situation, the percentage of code in read date and is date greater than is going to be a fraction of a percent of the source code of a particular project. So whenever you change the representation of date, you only have a tiny little fraction of code that you actually have to change. To the rest of the program, 99 point something percent of the program, there's no change whatsoever. That is called abstract data type programming, or ADT programming. And it's a very important concept. It eventually leads to object-oriented programming. Okay? It has to combine with some other stuff to become object-oriented programming, but nonetheless, by itself, it is an important concept. Okay, so now we can start to implement the program, just one step at a time, right? So now I can go to read_date.cpp. Nope, I changed my mind. Let's go to date.h. Okay, so at this point, I'm starting to think, you know what? I've been procrastinating long enough. It is finally time for me to specify how to represent the date. So what I'll do is I'm going to say, well, you know what? I'm going to represent the date using year, month, day after all. Okay. So we'll do the same thing as last time. We now start to define the members of a date. So we have year, we have month, and then we have day, which is actually day of month. But we'll just do it this way. Okay. Okay, now I have changed the definition of date itself. Do I need to do anything at this point? If I just want the programs to compile and use the same definition of date consistently, do I need to do anything about main.cpp, readdate.cpp, or is date greater than.cpp?
Save the first one so that changes are kept.
Exactly, because all three CPP or C++ source files, they all include the same header file. So by changing just the header file itself, all three source files, when I recompile, will now understand what the date is consistently. Is that okay? Okay, that's a very important step, because without copying and pasting throughout all the three programs, now I don't have to worry about, oh, main.cpp understands the date to be like this, and the next source file is understanding date as a different thing. It's not possible, because they all refer to the same header file. Okay, but I still have to go through the compiling process. Okay, I still have to go through G++, dash wall dash tick dash C. I still have to recompile because every time I change the source code, which means the CPP file or one of the header files that it refers to, I have to recompile because it's actually changing the definitions or potentially changing the definitions. So I'm gonna change this one extra dot, and the last one is read date. CPP. And now I can relink all the programs, right? So I can say G++-O main.o is date greater than .o and read date.o. And now I can finally rerun the program, and it's doing the same thing because I didn't change anything in the subroutines, right? Now if you look at these steps here, after a while they get kind of tiring because it's a lot of stuff, right? It's just a lot of typing. So in the next class or so, I'll tell you guys what to do. It's called a make file. It makes everything so much easier. Okay, but at this point we have to do it on the command line by ourselves. Code blocks kind of takes care of this automatically, but we also have a different program called a make file that can also deal with this. All right. So what we'll do next is to implement the program step by step. So I guess it makes sense to implement read date first, because until we have read date, it's kind of hard to hard code a date into a date variable for testing, for checking. So we'll go ahead and implement this program first. So with this one, I'm going to say std.cin. The first thing we read is into d.year, and the second one is into month and into day. There we go. So every time we use cin, we have to remember to pound include standard IO or IO stream. Sorry. There we go. And if you want to add some prompts, that's fine too. But I just want to kind of put a number in. What the heck? Why not? There we go. Month and day. There we go. So now we have a functional read date subroutine. And you can see that in read date, it does need to access the various components of a date. They're also called members of a date, of date. So year is a member of a date, month is the member of a date, and a day is also a member of a date. Okay, yep, go ahead.
So this is all three of these user inputs are going to be stored into D1 or D2?
Well, they will be stored into both because I have one call with D1 and one call with D2. Okay, let's switch back to main.cpp. And you can see that on line 14 I read into D1, on line 15 I read into D2. So if I recompile everything and relink everything, it will now read the first date into D1 and it will read the second date into D2.
So it'll store all three values into D1.
Correct.
And then subsequently
Yep.
D2.
Yep. So let's go ahead and test it. Okay, let's see whether that works or not. So we'll go back and recompile readdate.cpp, and this time I'll recompile everything with -g so that we can use GDB to test the program. Okay. And it complains about okay, double quotes. Change single quote to double quotes. Oh, forgot one more. Forgot one option. I should have used the G option, which changes all occurrences of the same line. Otherwise, it finds the first occurrence and change only that one, the first one. There we go. So let's do it again. And since I want to track down the execution of the program, I'm going to recompile everything with -g. So have main here, and then relink everything. And this time I can run the program with GDB, list the program, and I'm going to put a breakpoint on line 16 because I just want to make sure that I read the appropriate dates into D1 and D2. The comparison is still going to be pointless because it's still a stub, right? But you can see that I don't have to implement the entire program from start to finish in one single stroke. Okay, I can implement one function at a time, test that one function, and then move on to the next one. Okay, so that's the advantage of using top-down programming and using the concept of a stub. It only works for like simpler programs. It doesn't really work for complex programs. But in this case, it's working out. So we'll go ahead and run the program. It's asking for the year, month, and day for the first date. So let's just say it's 2007, November 23rd, and the second date is 2014, and the month is November 10th, which is today. And now we are at we are now on line 16, and we want to print what is in D1. And also print what is in D2. And you can see GDB is quite intelligent. It knows what D1 is, and it shows you the member of that structure automatically, which is really handy because now we can tell right away that D1 is a date, the year of that particular date is 2007, the month is November, and then the day is 23rd. So it's really kind of handy. The rest of the program, if I just continue the execution, it's not very interesting. It will still conclude the first date is after the second one, even though it's not, because it is a stub. But now I can move on. Okay, I have just verified that read date is now working just fine. I can now move on to the rest of the program. All right, so let's move on to the rest of the program. So we'll go ahead and edit is date greater than, and we'll work with this one. All right. So how do we conclude whether a particular date is greater or later than the second date? We compare
Years the most.
we compare year first, and then if the years are the same,
You go to months.
we compare the months, and if the months are the same, we compare the days. Okay, very good. All right. So how do you guys want to do this? There are several ways to do it. How many people like the concept of a ternary operator? One single expression, just one single return. Okay, let's do it that way first, and then we'll do it the more conventional way. Okay.
Which is the preferred way?
Sorry?
Preferred. Which is preferred?
It depends on which way is more clear to you and the people who will be reading your code. So it's kind of subjective, depends. Okay, so we'll go ahead and start with something. So if d1.year is greater than d2.year, that means for sure we know the answer is true, right? Okay, we'll give it a 1 here. But if that is not the case, then we have something else to deal with. Is that making any sense? Okay. But the something else to deal with has to start with year, d1.year being the same as d2.year. Because if d1.year is less than d2.year, there's nothing to compare anymore. We know the answer already. Okay, so we'll go ahead and deal with that one. So we have to say d1.year. If it is already less than d2.year, then we also know the. Oops, I need one more open paren here. Okay, that's a question mark. That's a colon here. Okay, there we go. Question mark. This one has to be a 0 because if the year of the first date is before the year of the second date, we know the answer is no for sure. But if they are the same, then we have to deal with the month, right? So now we have the same structure here. We have d1.month. If it is greater than d2.month, and I forgot about the parentheses are probably not needed because of the priority of the operators, but I just want to include them, just to be sure. Okay, so that is definitely a 1 because it is the first date is later than the second date. Otherwise, we'll check d1.month being less than d2.month. If that is the case, for sure we know it is not the case, so we can answer no. Otherwise, we need to compare the date. So by the time we get to here, I don't need to use a ternary operator anymore, because at this point I just need to say, oh, is d1.day greater than d2.day? Because I know everything else are the same. They have the same year and they have the same month. So that's the way I would do it with a bunch of ternary operators. Okay. Well, let's check it, right? All right, so in order to check the program after the implementation of is date greater than, how many files do I need to recompile? Not counting one, exactly. Okay, we only got one source file that we have to recompile. Because one, did I touch anything in the header file? Did I change the definition of the structures? No, okay. Did I change anything in main? Did I change anything in read date? So the only thing I changed was in is date greater than. So I can just recompile that one single file and then relink everything. So I have to retranslate one single chapter of the 3-chapter book and then just rebind the book.
Why would you need to relink?
Because every time you change, because the references will be at the wrong page. Okay, think of linking as figuring out the page number of a reference. So let's say you're writing a book. It has 3 chapters. Okay, so in chapter 1, there's one place in the word processor that you say insert the page number of section 5.3.2 of chapter 2. Okay, so you're looking for the page number, but you're referring to it as the section blah 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 of chapter 2. Okay, so when you rewrite chapter 2, the page numbers are going to reflow, right? It's going to change. That's why you have to relink, because you have to make sure that everybody else who refer to anything in chapter 2 would also have the updated page numbers. Is that okay? Okay. So that's why we have to recompile that one single file, which is over here, and then we have to relink all the files back into one to become the executable. Okay. So now we can actually run the program, and it should give us the ordering correctly now, right? So let's try 2014, November 1st, 2014. Let's try May 2nd. And it tells me the first one is after the second one. Okay, now let's go back and reverse the dates. So 2014, May 2nd, 2014, November 1st, and it says the first date is not after the second. The tricky cases are the ones that are equal, so you have to check it again. But at least we know the logic is kind of working, right? Okay, so now here comes the big question. The big question is, why do we have to go through all this trouble, just to recompile one single file and then do the relinking? I mean, what about recompiling just all of the files? I mean, there's nothing bad about it, right?
Unnecessary.
It's unnecessary, and it can be time consuming. Okay, but no one's going to agree with me that it's time consuming, right? Because we can actually check out how much time it takes to recompile one single file. So let's go back and recompile just is date greater than. There's a command called time in Linux, and what it does is not to report the current time, but it will measure how much time it takes for the command to execute. So it takes about 0.015 of a second, which is 15 milliseconds, to recompile this particular program, and that's in real time. That's the actual turnaround time of the entire job. And you say, 15 milliseconds, that's nothing. So what if I have to recompile everything, right? Let's check out how much time it takes to recompile the other 2 files. And let's just say, okay, that's, it has to do with the file access time and stuff like that, but there's still a fraction of a second, no big deal. Read date.cpp, once again, a fraction of a second, okay? So we really cannot see any benefits of not recompiling everything. But what if each source file has several thousands lines of code, and you have hundreds, if not thousands, of these source files? Then it starts to add up, right? how much time do you think it takes to recompile the Linux kernel?
It's 2 hours, maybe an hour and a half.
It will be measured at, the order of magnitude is about an hour or two. Okay, we just need the order of magnitude, right? And that's the recompiling everything. Now, if you change only one single file of one driver, source file, do you want to waste another hour or two just to see whether it works or not? Probably not, right? But then someone is going to ask, but what about linking? You still have to relink all the object files. Linking is fast, okay? If you, assuming you have all the object files already done and you're just relinking the Linux kernel or relinking a driver, the linking time is measured in, at the most, 5 seconds, 10 seconds. That's the order of magnitude. In a really bad case, I mean, if you have a really complex driver, it will take about 5 seconds to relink. But to recompile will take at least minutes. So we are talking about, a difference of, at least 10 to 100-fold comparing, just recompiling a single file or recompiling everything as opposed to recompiling one file and then relinking everything. So that's why you want to keep recompiling to a minimum. Okay, don't recompile anything that you don't need to recompile. But that's difficult because I have to keep track of all the changes that I have made to all the source files when I'm ready to run the program again. Well, it is. Okay, it's a lot of stuff to keep track of. And that's why we have a program called make. Okay, this is something that we'll talk about next time, not this time, because I want you guys to see how tedious it is to have to redo everything by hand and try to figure out which one needs to be recompiled. But for those of you who are curious, you can just say man make, and it will show you, how to use a make utility program. This is not really something that's easy to understand, so I would not be assuming that you'll be reading the man page of make and learn how to use it. But what I want you to do is just to kind of look up what it is for, okay? And then we'll talk about this on Wednesday. And I think it's about time for us to have the second exam. So on Wednesday, I'll also give you the practice exam for the second exam. Well, we gotta have those things going too. Okay. But are there any questions about the program that we did today? Not so much about the source code itself, but more about how do we keep things separate in a way so that if I need to make any changes, I can make minimal changes to only one part of the program without impacting the rest of the program. Okay? The TV analogy works really well, okay? Because without that remote control, that has a button called channel up and channel down, then you're basically saying it's open, okay? There's no encapsulation, there's no single remote control to say, oh, regardless of how it is implemented, press this button to move up to the next channel. Then you're dealing with something that's a lot more insidious because now you actually have to understand what is NTSC or the transmission signal standard and all that stuff just to change channel. But by using the remote control, you don't have to relearn anything. When you move from a traditional broadcast to a high definition broadcast. Are there any questions at this point? All right, well, we are kind of short for about 50 seconds today, but that's okay with me. Let's go have lunch. And this time I didn't talk about cookies, so